Okay, this will be a two-sample t-test. This is a hypothesis test for means. We know it's a mean problem because they say the word mean or average and they give us a standard deviation. And we know it's two-sample because we have two samples. Okay, pause the video and read the question. Okay, hopefully you did that. So we want to know whether people on average will put more ice cream in a larger bowl than a smaller. The sample suggests that so. The sample says in a large bowl, the average is, what is that, about 1.5 ounces more than in a small bowl. We want to know if that was just a sampling fluke or if that is statistically significant. So the first thing we do, write down what mu represents. Remember, we never mention either of the groups in this sentence. So here mu represents the mean amount of ice cream in ounces people will put in a bowl. Our null hypothesis is always every single time that the groups are the same, that mu1 equals mu2. The average for small is the same as the average for large. Why is large group 1? Because they had the higher average. Our alternative hypothesis, as long as we pick the correct group 1, our alternative will always be mu1 minus mu2 is positive, which means the average for group 1 is bigger than the average for group 2, as long as we're doing a one-sided test. And then we type everything in our calculator and it does all the work. So we go stat and test. This is a two-sample hypothesis test. That's button 4. We know the sample statistics. If we know the actual data, we would put them in L1 and hit data. But we don't. We know the stats. So we want to be careful and make sure we get everything in the proper place here. Here's group 1. Here's my X bar, my S, and my N, and similarly for group 2. Our alternative hypothesis was that mu1 was greater than mu2. We always hit no on pooled. And we hit calculate. And there's our p-value, 0.02. We're testing at a 5% level. That's our alpha level. So our p-value is less than alpha. Anytime we're less than alpha, we reject the null and accept the alternative. So as soon as we say accept the alternative, we have to write down what that means. What does this statement mean? It means we have strong evidence that the average for 1 is bigger than the average for 2. So we have strong evidence that the mean or average amount of ice cream people will put in their bowl for a large bowl is more than the average amount in a small bowl. So there's this follow-up question we want to answer, and we'd say, yeah, it seems, or at least these data suggest that bowl size influences portion size, and it seems like the bigger bowl you give people on average, the more ice cream they'll put in it.